All right, so thank you for clicking in and looking at session 2 of the LEAP practice test. We're going to just go ahead and jump right in with problem number 14. Okay, so in the right triangle, angle B is not equal to angle C. So the measures are not equal. So this is not a 45-45. Let sine of B equal R and cosine of B equal S. What is sine of C minus cosine of C? Okay, so let's look at what sine of B and sine of C are. So remember, this is trig, so you need to remember SOHCAHTOA. That will not be on your reference sheet. So you need to just remember, you need to have this memorized. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So you do need to have that memorized, those ratios, so you know what's going on with any of the trig problems. Okay, so sine of B is R. So let's look at exactly at what sine of B is. Sine is the opposite side over the hypotenuse. Give me just a second. Okay, so let's look at what sine of B is as far as what the sides are. So sine is opposite over hypotenuse. So the side opposite of angle B is AC. So we're going to do this. Sine of B is AC over the hypotenuse, which is BC. Okay, so that is R. All right. Cosine of B is going to be the adjacent side of B, which is, the adjacent side of B, which is AB, over the hypotenuse, which is BC. And that is equal to S. Now let's look at sine of C. Sine of C, and do the opposite side, which is BA, or AB over BC, which we already know is S. So cosine of B and sine of C are equal. And then cosine of C is the adjacent side, AC, over the hypotenuse, BC, which is R. So sine of C is S, cosine of C is R. That leaves us with S minus R, which is C. So basically what this boils down to is that sine of B is equal to cosine of C. Sine of one angle is equal to cosine of its complementary angle. B and C add to 90 degrees, so they are complementary. Okay, let's look at 15. In the figure, point P will be the center of dilation of triangle ABC. Point P is collinear with vertices B and C. So we are going to scale factor. We're going to dilate this by a scale factor of 3. Now I am just going to guesstimate it, but you should still get the idea. Okay, so let's look at from A to P. This is about 4 centimeters. So this is a scale factor of 1. 4 centimeters away is a scale factor of 2. And 4 centimeters away right? So let's put that at 0. 0 to 4. 0 to 4. And 0 to 4. So this would be A prime. Okay. 0 to b is about 2. Scale factor of 2. Scale factor of 3. This would be b prime. And if I were to connect, this line and this line would be parallel. So a prime, b prime is going to be parallel to ab. Now again, this is not perfectly drawn because it's me. So this is side a prime, b prime will be parallel to side AB. Let's do the same with C. All right, it's about 3.5. Scale factor of 2. Scale factor of 3, this would be C prime. Okay. A prime, C prime, and AC will also be parallel. So this will be parallel to. And then BC are on the same line. They are not parallel. In fact, it's all, because P is collinear with BC, it's also collinear with B prime, C prime, so they're all on the same line. So we'll lie on the same line as. This should, you see how this is a drop down? We don't have, for some reason, the options weren't printed or weren't put on there, and that's okay. That's okay. You get the idea. All right. So number 16, given the two triangles shown, find the value of x. So we need to determine whether or not these are similar triangles. This is a calculator question, so I'm going to use my calculator, make life easy on me. Okay. So in order for this to be a triangle, this has to add to 180 degrees. So we're going to do 180 minus 68 plus 38. And that leaves us with 74. So this angle is 74 degrees. Okay. If these two angles are both 38 and these two are both 74, then in order for this to be a triangle, this also has to be 68. So they have angle-angle similarity, or angle-angle-angle similarity, because their angles are all congruent. So they are similar triangles. All right, so let's figure out what x is. So 6 lies between 68 and 74. 15 lies between 68 and 74. So 6 and 15 are proportional. Okay, 10 is between 74 and 38. X is between 74 and 38. So this is going to be 10 over x. So remember, these two are from triangle ABC. These are both from triangle DEF. We want to make sure that we've got corresponding parts. And then to solve, we're going to cross multiply and divide. So this is 6x equals 150. We just multiplied. We're going to divide both sides by 6, and x equals 25. Okay, number 17. A dilation with center at 0, 0 and scale factor k is applied to MN. Okay, so we're going from, let's see. Okay, we're going from 0, 0. We have, let's make this segment MN. Okay. All right, so we just want to see which of these is correct. If k is greater than 0, then mn will be greater than, or m prime n prime will be greater than mn. Like if I plug 2 in for k, yes, this would obviously get bigger. But what if I plugged in 1/2? This would obviously shrink down by half. That's still greater than 0, but it's going to shrink, so obviously this is not correct. If k is greater than 1, then mn will increase. And that would be true if I doubled my scale factor, then my length would double. So B would be correct. C, if k is between 0 and 1, then mn will be, or m prime n prime will be smaller than the original. That is also correct. If it's a fraction or a decimal that is smaller than 1 but larger than 0, it's going to be like multiplying by half. It's going to be like cutting it in half or making it smaller. If k is between 0.5 and 1.5, then m prime n prime will be smaller, and that's not true because if k is equal to 1, it's not going to change. If k is smaller than 1 but great, like 0.75, then this would be true. But if k is 1.2 or 1.25, this would not be true. It would be larger. So D is not correct. E, if k is equal to 1, then m prime n prime is going to be equal to mn. That is true. If you multiply something by 1, it does not change. So a scale factor of 1 does nothing. If my scale factor is 5, then the length is 5. I'm sorry. If the scale factor is half, then I cut my length in half. And that is also true. So B, C, E, and F are all true statements. Okay. Let's move on to number 18. All right, 18. Triangle ABC is dilated from a center A by a factor not equal to 1 to form triangle AKL. So we have triangle ABC, and then it is dilated to form AKL. So these will be similar. So this would be A, this would be K, this would be L. Okay, AB and AK are on the same line. Is that true? That has to be true because K is the dilated version of B. The line containing BC is parallel to the line containing KL. That would also have to be true. Angle ABC is congruent to angle ACB. That is not necessarily true. If this were an equilateral triangle or an isosceles triangle, then we could say that, but we don't know what my angles were. That doesn't necessarily have to be true. Angle ABC is congruent to angle AKL. So this angle and this angle, and that is true because it should be, if these are similar, then they should have the same angles. All right, triangle ABC is similar to triangle AKL. That is true because if you dilate, you create a similar triangle. Triangle ABC is congruent to triangle AKL. This one cannot be true because the scale factor was not equal to 1, so they cannot be congruent. Okay, so everything but C and F are true. 19, some probability, some of my favorites. We have a two-way table, and that two-way table shows us students who are right-handed, left-handed, and ambidextrous, and whether or not those students are male or female. So part A, what is the probability that a randomly selected student in class is female, given that the student is right-handed? So if I didn't have this given, the probability that the student in the class is female, well, that would be easy. We could just say, okay, there's 14 females, and there's a total of 30 students, so 14 out of 30. But we have this given, which means we're not looking at the entire total. We are looking at just the students that are right-handed. So let's look at right-handed students. That is 23. Only 12 of them are female, so my probability is going to be 12 out of 23. When something is given to you, that shrinks the pool you have to choose from. If I just said, what's the probability of my student being female and right-handed? Well, there are 12 of those out of the total. But the probability of her being a female, given that she's right-handed, well, we don't care about the left-handed people. We don't care about the ambidextrous people. We're only looking at the right-handed people. So that given shrinks the pool that you have to select from. Okay, part B. One student will be selected randomly from the class. Consider the events. The selected student is female. The selected student is right-handed. Which statement about these events are true? So if we look, we have independent and dependent events. So if an event is independent, then the event by itself is equal to the event given another. It doesn't necessarily mean that the outcome is dependent on the other outcome. It just means that whether or not that person is right-handed isn't going to have any effect on whether or not this person is female. It's not going to change the probability. Like the probability of a total and the probability of a given are going to be the same. So let's look at this. What's the probability that the student is female? Okay. So that's X, student is female. The probability of the student being female. Well, there are 14 females out of a total of 30. So 14 out of 30. And as a decimal, is 4.67, so about 47%. Now, why? The selected student is right-handed. So let's look at just right-handed people in general. There are 23 right-handers out of a total of 30. So 23 divided by 30. That's much more likely to occur. So that would be about a 77% chance. Now let's look at given another. Let's look at probability of female given that she's right-handed. Well, we already did that earlier. That's 12 out of 23. So X given Y is 12 out of 23, which is about 52%. And just for fun, let's do Y given X. And that would be there are 23, I'm sorry, given that they're female. So that would be right-handed given that they're female. So that would be 12 out of a total of 14 females, which we can already tell that's going to be the highest probability on this page. And that is an 86%. Okay, so none of these are equal, which tells me that these events are not independent. Okay, so let's look at our answer choices. The events are independent because the number of right-handed students in the class is larger than the number of female students. That has nothing to do with anything. The events are independent because the number of categories for dominant hand is different from the number. That has nothing to do with anything either. The events are not independent because for one of the dominant hand categories, the number of female students is 0. Again, has nothing to do. These really don't tell me anything. D, the events are not independent because the probability of X, which is 47, is not equal to the probability of X given Y, which was 52. So A, B, and C sounds like a lot of fancy stuff, but that doesn't tell me anything about the probability, because probability is a ratio. Something being 0 doesn't really affect the ratio. Something, there being a number of categories still doesn't really affect the ratio of one category to another. So the answer is D. In order for events to be independent, that probabilities have to be the same. Okay, let's move on to number 20. Number 20 is one of those that looks overly complicated, but then is like not bad at all. It is a simple trig problem. All right, we have a spring attached at one end to support B. So here's support B. So it's attached to B. The other is attached to a collar on A that can move up and down. B is 3 feet away from the support, and it creates angle theta. Okay, part A, when angle theta is 28 degrees, what is the distance from point A to point B to the nearest tenth of a foot? So because this is a spring, as this moves up and down, this is going to stretch and shrink. So we have 3 foot. So let's look at this. Let's make us a little triangle over here. We're looking for this length. We have that this is 28 degrees and this is 3 foot. So what is this length? So again, it's some trig, so we need to remember our SOHCAHTOA. So let's look at this. We have the adjacent sides of the angle and we're looking for the hypotenuse. Adjacent and hypotenuse is cosine. So cosine of 28 equals 3 over my hypotenuse. I don't know my hypotenuse, so I've got to solve for it. So 3 divided by my hypotenuse is cosine 28. Now remember with division, 10 divided by 5 is 2, 10 divided by 2 is 5. So you can take the number you're dividing and swap the two dividends. So H is going to be equal to 3 divided by cosine of 28. And cannot do this part without a calculator, so let's do this. 3 divided by cosine 28. Make sure you use your parentheses to be accurate. And we get 3.39. And we want it rounded to the nearest tenth of a foot. So that rounds up to 3.4. So that is 3.4 feet. Okay, part B. When the spring is stretched and the distance from point A to point B is 5.2 feet, what is the value of theta? So now we've stretched this out a little bit extra. This is still 3 feet. This is now 5.2. We are missing theta. So it's going to be set up the same way. It's still the adjacent and hypotenuse. Cosine of theta equals adjacent over hypotenuse, so 3 over 5.2. Now I want theta by itself, so I have to undo cosine. The opposite of cosine is cosine inverse. Theta is going to equal the cosine inverse of 3 divided by 5.2. So, second cosine, to get your inverse, we're going to put this in parentheses. 3 divided by 5.2. That leaves me with 54.765, which will round off to 54.8. All right, 21. Oh, I like 21. We have a circle O with points A, B, C, and D on the circle. AD is congruent to, or arc AD is congruent to arc BC. So arc AD is congruent to arc BC. Let's call both of these x. Let's say these are x degrees. The measure of AB, of arc AB, is twice the measure of BC. So this arc is double BC. So this is double x, or 2x degrees. Part A, the measure of angle ACD is blank the measure of angle ADC. So ACD is this angle, which captures arc AD. ADC is this angle, which captures arc ABC. So arc AD, which is angle ACD, is X. ADC, which is arc ABC, is 2X and X, which is 3X. So to get from 3X to X, I have to divide by 3. So ACD is 1/3 the measure of angle ADC. So this is a third of this. Part B, the measure of ADC. So we already did ADC. We already know that's 3X. Is what the measure of BCD? So BCD is this angle, or let's not make it right, which captures X and 2X. So this is also 3X. So these two angles are equal. So is equal to. All right, so not too terribly bad. All right, let's look at 22. Is this the last one? I think this is, nope, we got two more, 22 and 23. 22. Triangle ABC is shown in the XY coordinate plane. This one is going to be rotated 180 degrees clockwise around the point 3, 4. So here's my origin. Let's do this, and let me put an X around 3, 4. So 3, 4 is where C is. We're going to rotate it 180 degrees. Whew. All right, so that is 90 degrees. And 180 degrees. All right, so let's look at this. Here's C, here's A, and here's B. All right, so the coordinates of A prime will be the same as A or different. So here's A prime. So actually, let me label this C prime, B prime, and A prime. Okay, coordinates of A prime will not be the same. Coordinates of C prime, well, considering we rotated around C and we didn't move it, that should be the same. The perimeter of the triangle, the distances did not change, so the perimeter should be the same. The area should also be the same. The measure of angle B, rigid motions do not change. Rigid motions don't change the angle, so the angle measure should stay the same. The slope of A prime C prime and the slope of AC will also be the same. See how it makes one continuous line? So the slope does not change. Okay, and last but not least, number 23. Okay, the figure shows lines R, N, and P intersecting to form angles numbered 1, 2, 3, 4, 5, and 6. All three lines lie on the same plane. Based on the figure, which of the individual statements would provide enough information to say that R is perpendicular to P? Okay, so we are not worried about line N. If it makes line N perpendicular with anything, I don't care. We just want to see, do these angles make R and P perpendicular? It is important to note that this says not to scale. It's not going to look perpendicular, and it shouldn't look perpendicular, because if it looked perpendicular, then there wouldn't be any question and it would just be confusing, and we just want to know based off of the information, not on the picture. Okay, so if angle 2 is 90 degrees, that is this angle right here. If this was 90 degrees, then angle N and P would be perpendicular. But that's not what it asked. It asked for R and P. So this tells me nothing about R and P. So A is not going to help me. Okay, B, angle 6 being 90 degrees. Okay, well, angle 6 is between R and P. So if that is 90 degrees, R and P would be perpendicular. So B could be a possible answer here. C, if angle 3 is equal to angle 6. Vertical angles are always equal no matter what the measure is. Now, a lot of people are going to say, but look, we already said 6 was 90 degrees, so if 3 is 90 degrees, but these say which of the individual statements. The individual statement is angle 3 being equal to angle 6. Angle 6 being 90 degrees has no bearing on this. Angle 6 and angle 3 are going to be equal no matter what. So this on its own is not enough to tell me. And that's where people are going to mess up. They're going to look at this as a whole and not as individual. Number 4, the measure of angle 1 plus the measure of angle 6 being 90 degrees. So if this whole thing is 90 degrees, that would make angle N and angle P 90 degrees apart, which would make them perpendicular. But again, I'm not looking for N, I'm looking for R. So D doesn't help me. 3 and 4 being 90 degrees. So again, that puts line N and line P as being perpendicular. Okay, and then 4 and 5. So 4 and 5, that forms angle P. I'm sorry, that's formed with line P and line R. So between P and R would be 90 degrees. That would make R and P perpendicular. So my only correct answers here are B and F. Okay, question 24 and question 25 are constructive response. So you can find that in the session 2 constructive response video. If you have any questions, feel free to email me, and hope you guys have a great day, and I will see you soon. Bye.